So on the front of the sheet from the back of the room, you are supposed to find one of these on your reference sheet, and then we're going to figure out which one it's exemplifying and do a trade. What was that? Yeah. We need the tests back, the quizzes back. So if someone wants to collect those, otherwise I need to get going here. Can anybody find something on the reference sheet that looks like this? It says sine times cosine plus cosine times sine. Okay, sine times cosine plus cosine times sine. It says the sine of A plus B. Does everybody see that? This is just about, can you find it on the reference sheet? So this becomes sine of A plus B, but what are A and B for this particular example? 118 plus 62, which would then total 180. Is that right? And then we're just going to leave it at that, okay? Number 2 says cosine, cosine plus sine, sine. If you have no idea what I'm doing, you need to ask. Cosine, cosine plus sine, sine. Find that one? So it's cosine A minus B. And what are A and B here? A is 47 and B is 17. And 47 minus 17 would be 30. Okay, now could you go to 30 and tell me what the cosine is? Square root of 3 over 2, maybe? Okay, what was the sine at 180? I forgot that last step. Sine at 180 is 0, right? All right, so here's 2 tangent ones. Can you find the one on the reference sheet that has a plus at the top and a minus at the bottom? Plus at the top, yes, okay, it's tangent A plus B. So this would be tangent of 12 plus 168, which is 180. And the ordered pair at 180 is negative 1, 0. So tangent would be y over x, which is 0. Okay, I feel like some of you have no idea what I'm doing. Brandon, are you doing this with us? Okay. So you should be looking at this side of this section of the reference sheet. Everybody good? All right, I am going to move down and talk about, oh, let's do a radian one for fun. Let's do number 6, cosine, cosine minus sine, sine. Cosine A plus B. Okay, so this one would be cosine of pi over 9 plus 8 pi over 9, which would be 9 pi over 9, which is pi. Okay, and the cosine at pi is what? The cosine at pi is negative 1, right? We good? All right. Let's do this number 7. Tangent with a minus on top and a plus on the bottom. Tangent A minus B. And our numbers are 23 pi over 18 and 5 pi over 18. If we subtract those, we get 18 pi over 18, which is Okay, and the ordered pair at pi was -1, 0, so what's the tangent? 0 over -1, which is 0. All right, you get the idea? These are just trades, okay? On some of them, you can't do anything besides combine. So look at number 12. Sine times cosine minus cosine times sine. That's a sum and difference one. Anybody find that one? Sine times cosine minus cosine times sine. Sine times cosine minus cosine times sine. Right here, right? Sine A minus B. What are A and B, though, on this question? The A was 5 theta, and the B was 3 theta. Now we can't do anything with that except simplify it. So the sine of 2 theta, and we're done. There's questions like this on the next quiz. Can you get these right? Just trading them out. Okay. Some of these have negatives in them. Let's do 14 and then we'll be done. Sine cosine minus cosine times sine. Ew, this is really weird. They should have written it like this, guys. There should be some parentheses in here. And then I have no room. So sine times cosine minus cosine times sine is sine A minus B, you said? I'm trusting you. Okay, and A is what? -6x, and B, it says minus B, and B is positive 3x. So we end up with -9x. Now, look one more place for me. What can you do when there's a negative? There should be one that says something like this. It's called the even odd one rules, maybe? What can you do when it's inside? Move it out front. So this is the opposite of the sine of 9x as well. All right, we're going to go to the notes for today. I just wanted you to know where those were on your reference sheets. All right, so we're mostly talking about these today, the sum and difference ones up here. We will eventually do all of, or the majority of those, not all of them. Here's a quick example of why we have these. In order to be able to write the sine of 15 exactly, I don't know what the sine of 15 is. It's not in my unit circle. But I could say it's 45 minus 30. Does everyone get that? 45 minus 30 would be 15, and 45 and 30 are on my unit circle. So then I would fill in that crazy rule, sine times cosine minus sine times cosine. They have it in funny order. Anyway, put in the values, and you get this lovely. Isn't that a beautiful exact answer? Okay? Kind of makes me want to cry. So on your notes, there's one for 375, which is 330 plus 45. It's cosine A plus B, so they did cosine, cosine minus sine, sine. And they filled in all those values, and they got something very similar to the other one. All right, we're going to try this one together. Somebody come up with a way to get -15. Use, okay, 30 minus 45 will work. There's more than one way that would work, okay? 30 minus 45. So we have cosine A minus B. What does cosine A minus B say on your sheet? Cosine A minus B says cosine A cosine B plus sine A sine B. Okay, so what value am I putting in for A? 30, and for B? Positive 45, right? Because we're using The minus in here is part of the problem. And then it would be plus sine 30 sine 45. Okay, we need to substitute in values. Flip your sheet over. The cosine at 30 is square root of 3 over 2. The cosine at 45 is square root of 2 over 2. What's the sine at 30? And the sine at 45? Okay. Multiply these together, and what do I get? Square root of 6 over, 4, right? Just kidding. Now, can I reduce that? Nope, because one's in jail and one's not. If I multiply these two together, I get square root of 2 over 4. So this is the answer, or you can combine it into one fraction. That's the exact answer for the cosine of negative 15. Disgusting, right? Okay, but all it is substituting in to the formulas that are on your sheet, using your unit circle to find the values. Should we do a tangent one? Okay. Tangent of 15, how can you come up with 15? 45 minus 30? You could do 60 minus 45. Okay. You do 135 minus 120. All right. Tangent 45 minus 30. What's the rule for tangent? Can I substitute as we go this time, guys, to save a little writing? Okay, tangent of A minus B is tan A. What's A, guys? Minus tan B, which is all over 1 plus tangent of 45 times tangent of 30. Now we have to put in values. Ugh. Okay, tangent of 45, y over x at 45. 1. Tangent at 30, y over x at 30. Would be 1 over square root of 3 or square root of 3 over 3. We'll deal with that in a minute. Down here we have 1 plus, what's the tangent at 45 again? 1 times the tangent at 30, 1 over square root of 3. We could rewrite this as square root of 3 over 3 and rewrite this as square root of 3 over 3. I kind of just want to leave that. Can we just leave that? It's really disgusting, but I mean, in theory, we should multiply top and bottom by the conjugate to get rid of the radicals in the denominator, but I don't want to go there. And I do hereby solemnly swear it's not on the quiz, okay? Let's do one in radians, though. Which one would you like to do of these in radians? By the way, you want to do 4? Okay. If we change this to degrees, what is negative 7 times 180 divided by 12? Somebody? Negative 105. How could you get a negative 105? Anybody know? Using all the numbers on your unit circle in degrees. 60 minus 1. How about, what do we want? Negative 105? 45 minus 150? Does that work? That'd be negative 105? Okay, so what is 45 in radians, though? Oh my gosh, guys, pi over 4, and minus 150 would be minus 5 pi over 6. Okay, now we're going to write out what the rule is. The rule for cosine A minus B is cosine A times cosine B plus sine A times sine B. Well, what are A and B here? pi over 4, 5 pi over 6, pi over 4, 5 pi over 6. Okay, I use degrees because I can't think in radians how to get a 7 pi over 12, but it was negative 105 in degrees, so that was 45 minus 150 was one of the options. So then I went back and put in the radians for 45 and 150. All right, cosine at pi over 4, anybody? Root 2 over 2. What is the cosine at 5 pi over 6? Okay, what is the sine at pi over 4? What is the sine at 5 pi over 6? Okay, if I multiply these together, I get negative square root of 6 over 4. Multiply these together, I get square root of 2 over 4. So the only thing I could do is combine them. Okay, you have several of those on homework. We may have forgotten to put it on the quiz. Oh, thank you. Yeah, I should just rewrite that because it's a mess. All right, moving on. This is just like we were doing on the worksheet a second ago. So find me this one. Where's tan minus tan over 1 plus tan tan? It's the tan of A minus B. What is our A and our B? Okay, so that would give us the tan of negative 1x. Now, what does it say for even and odd rules for tangent? You can move it out front, right? So it's negative tangent x. What? Yes, because secant is even, so it just goes away. Yes. Yeah, they're not listed by even and odd. Cosine and secant are even, all the rest of them are odd. Yep, got it. All right, number 5. You have this on your sheets, guys. Sine, cosine plus cosine sine, real quick. Sine, cosine plus cosine sine. Okay. Which would trade to, what are A and B? 20 and 10, so you get the sine of 30, which if you had to trade for that value would be 1/2. Okay, what about this one? Tan plus tan over 1 minus tan tan. And what are A and B? Okay, use your calculator. What's 1/9 plus 5/36? Math, enter, enter. I think it's actually 1/4. So that means it's down to 1/4 pi. What's the tangent at pi over 4? Because it's square root of 2 over square root of 2, which is 1. All right. Can I skip 7? You got the idea here? Well, let's do 8 because 8 doesn't have all numbers. So it's actually an easier question because we get to stop sooner. What is sine cosine minus, oh, I think they're trying to trick us. Sine cosine minus sine cosine, but they switched the things here. I'm thinking we could rearrange this. Right, because you can multiply in any order, so I can flip-flop this multiplication. Does that look more like what's on the sheet? Sine cosine minus cosine sine? Sine cosine minus cosine sine is sine of A minus B. They were trying to trick us. Okay, and what are we putting in for A and B? Can we do anything with that? Okay, So that's going to be on the quiz. There's just like those trades where you just look and see what's on the sheet. I'm not taking the sheet away and you're good. Everybody okay? And I don't think I switched them around funky to confuse you. All right, the next thing we're going to do is proofs using these. So this is a verify question. So what you do, this is number 9, is you write out what the sign A minus B would be. Okay, so the first step is sine of pi minus x equals, there's a right-hand side there. But the rule for sine A minus B says what on your sheet? It says the sine of A, which should be the sine of pi, times cosine of B, which we're using x, sine cosine minus, okay, cosine of A, which is pi, times sine of B, which is x. All right, then what do you think we need to do? We can't because it's a verify. It can only work with one side. I'm not going to repeat that 1,000 more times. Some of you tried on the thing. You can't do a verify by working with more than one side. We're going to evaluate these by using the unit circle, guys. At pi, the ordered pair is -1, 0. So what's the cosine? And the sine, nope, this was wrong. This said sine and I said cosine and wrote cosine. Sine is 0. Cosine is -1. Okay, what happens then? 0 times cosine is 0 or nothing. Minus -1 times sine would be positive sine. So you could have written 0 plus sine x or just sine x. Does that equal the right-hand side up here? Okay. That's a verify. So what did we do? We expanded it, and then we evaluated it using the unit circle, showing all of our steps. Is there another one? No, they're not at all. Okay, sine A plus B is sine A times cosine B plus cosine A times sine B. You really don't need to write that out. I just did. Okay, so we're supposed to verify 270 plus theta. So it would be sine of 270 times what? Okay, but I'm expanding this. We have to write it all out because it's a proof. So we have to put these in. Sine of A times cosine of theta plus cosine of 270 times sine of theta. Now we can evaluate. And at 270, it's 0, -1, so the sine is -1, like Martin said, I got it wrong last time. Then cosine of theta plus the cosine at 270 is 0 times sine of theta. We can't replace theta. So we have negative cosine plus 0, right? Is that what we were supposed to get? So then you can do a proof like that on the next quiz, especially if I like put little blanks to remind you what you're supposed to do. Okay. This is an equation. It is not a verify question. Yeah, this is a hot mess. Okay. We have to expand this and then expand this and then figure out how to solve. Okay. So cosine of A minus B here, someone read that one? Cosine of A, which would be pi over 4, times what? Cosine of B, which would be x. And then it's plus, right? And it's sine of pi over 4 times sine of x. Okay, it'll get better. Minus, what does sine of a minus b say? Sine a, which is pi over 4, times cosine b, which is x, minus cosine of pi over 4 times sine of x. And that's all supposed to be equals -1, but I don't have room. Okay, we got some good news, because what are the sine and cosine at pi over 4? Yeah, square root of 2 over 2 times cosine of x, plus square root of 2 over 2 times sine of x. Now, can we distribute this negative here, guys? What is this going to say? Minus, what's the sine at pi over 4? Square root of 2 over 2 times cosine x. Now remember, we're distributing this negative, so we end up with what? Plus, because it's a minus a negative, and it's square root of 2 over 2 sine x equals -1. Squeezed in there. Okay, something goes away. What goes away? Those are subtracted. What can we do with these two? Add them together. What is blah sine of x plus another blah sine of x? 2 blah sine of x. So what happens when I multiply that blah by 2? Doesn't that cancel out right there? Because it's all multiplication. So I have square root of 2 sine of x equals -1. Okay, that was a question on the quiz yesterday. It was in a little bit different form, but if you divide both sides by square root of 2, what does -1 over square root of 2 become? Negative square root of 2 over 2. And where is the sign? Negative square root of 2. Weren't there directions that said 0 to 2 pi at the beginning of this? Okay, so x equals, I'm thinking here, negative square root of 2 over 2, and here, which would be 5 pi over 4 and 7 pi over 4. After all that craziness? Is this where you want me to say there might not be one of those on the quiz either?
Maybe. Tiny bit.
Okay. Yeah, we're not doing that one. Let's try 13. What's the rule say for tan? Oh, wait a minute. I see a shortcut from the very beginning. Doesn't this say exactly the same thing? Tan of this plus tan of this would be what? 2 tan of that equals -2. Wow, what could we do with that? Divide by 2. So now we have tan of black equals what? -1. Okay, now let's try our disgusting tangent trade thing with an a and a b. Because tangent is ugly because it's got a fraction, right? It says tan a, which is pi, plus tan b, which is x, because the minus, I'm using from the minus formula there. No, I'm not. It's supposed to be minus, isn't it? Tan a minus b is tan pi minus tan x, all over 1 plus tan pi times tan x equals -1. Now what? Oh, you got this. You got this. What can we do? What can we put in there? What can we evaluate? Pi is -1, 0. So the tangent of pi is 0 over -1, which is 0. So this is a 0, and this is a 0. So what's left on top? What's left on the bottom? 1 plus 0 times tangent of x would be... Guys, there's no parentheses, so what do you do first? Multiply, right? So that becomes 0 plus 1 is 1. So what is that really saying? Yeah. We take the opposite of both sides, or whatever you want to do to rearrange that. Tax. Yeah. Nice.
Yay.
We're taxing 100%. Thank you. At least it wasn't a sex one, right? It's only a tax one. All right. Tan x equals 1. That is true twice. I know tan is not your friend. But where is the tangent 1 on the unit circle? Yes, at pi over 4 and... Nice. If you put the y over the x, it happens at pi over 4 and 5 pi over 4. Well, actually, because we noticed the shortcut, it wasn't as bad as it could have been, by far. All right. Why are we doing this? Oh, this is where you're going to get to use these eventually. Can you go to worksheet 9A real quick? Number 10 at the bottom. Let's just see if we can get one of these done. Yes, this is number 10 at the bottom. This says some angle, two angles, alpha and beta, are both less than pi over 2, which puts them in quadrant 1. And angle alpha has a sine of 5/13. Anybody know what that other side would be if we do Pythagorean theorem fast? It's 12. Okay. Sine of beta is 4/5. Anybody know what that side would be if we did Pythagorean theorem real fast? Okay. So, using this triangle right here, alpha triangle, what's the cosine? You just told me up at the top the sine was 5/13. The cosine is 12/13, and the tangent is opposite over adjacent is 5/12. Okay? On this particular one, the sine was 4/5, the cosine is 3/5, and the tangent is 4/3. Okay. This is where you're going to have to be able to use this on a quiz eventually. The sine of A plus B. Can someone expand? What does that say? Did I write it out right? That's supposed to say cosine. Now guess what we get to do? Yes, put the numbers in. What's the sine of alpha? 5/13 times the cosine of beta. 3/5 plus the cosine of alpha. times the sine of beta. Okay, it is, but it's good news. When we multiply these together, we get a common denominator. So this becomes 15 over 65 plus this becomes 48 over 65. We add the top, 48, 63 over 65. Now, by the way, that was all sine, not cosine. Okay, I don't know that you have one of those on your homework yet, so I'm actually going to stop and not do any more of those. But just because we have a little extra time on the video, let's go back. That one's too easy. What do you want to revisit? One of these disgusting ones? Okay, real quick, 11 pi over 12 is 165, so I chose 45 and 120 to add up to 160. So this would say the cosine of, so how do you expand that? What does your sheet say for cosine A, cosine A times cosine B, which is 2 pi over 3, minus sine A times sine 2 pi over 3. All right, so give me some values off the unit circle. No, how about square root of 2 over 2? 2 pi over 3 cosine negative 1/2 minus square root of 2 over 2 again, right? Times positive square root of 3 over 2. So what happens when I multiply this together? Negative square root of 2 over 4. Multiply across the top and the bottom. What happens over here? So we have negative square root of 2 minus the square root of 6 all over 4. That's all the verify you had was 2 of them on your paper? Okay. I could do this last one real fast. The sine x cosine b in the bin is fine. Thank you. Plus cosine sine. Okay, that's the first one. And then it's plus. When it's minus, it goes sine cosine. And then minus cosine sine. Equals 1. Okay, do these parentheses doing anything? Because it's plus, they're not really doing anything, right? So can we combine any or get rid of any terms? This is the same, right? And then these are the same, so we could add them together. 2 sine of x times cosine of pi over 3 is equal to 1. What's the cosine at pi over 3? I think it's 1/2, isn't it? Nobody has a unit circle? Cosine at pi over 3 is 1/2. So what do we have left? 2 times 1/2 is 1. So where is the sine of x? 1. The sine of x is 1 at one spot. Pi over 2. Okay. We went really fast, but do you get the idea, guys? The steps are find things on here, write them out, and then possibly you have to evaluate by using your unit circle, right? That's pretty much it. This is my last magical slide. This is on the page that was on the back of the other homework. Remember all the bookwork was stapled together? Okay, it's the last page.